Hello friends, I am going to explain you weighted point method for the material selection. Weighted point method is useful in machine design for the selection of material of component. What is material selection and weighted point method? Material selection is a step in the process of designing any physical object. In the context of product design, the main goal of material selection is to minimize cost while meeting the product performance goals. In the weighted point method, each material requirement or property is assigned a certain weight depending on its importance to the performance of the part in service. A weighted property value is obtained by multiplying the numerical value of the property by the weighting factor. Steps in weighted point method. There are total three parts of the weighted point method. Part 1 is calculation of weightage points. Part 2, it is tabulation of weightage points. And part 3 is selection of material. Let us understand weighted point method by an example. It is required to select a material by the weighted point method. There are four candidate materials: low alloy steel, plain carbon steel, stainless steel, and chromium steel, which have passed through screening test. For a particular application, the designer has given 5-point weightage for ultimate tensile strength, 3-point weightage for hardenability, and 2-point weightage for cost economy. Following table gives the data for the candidate materials. In this table, the values of material properties are given for the selected materials. Part 1 is calculation of weightage points for low alloy steel. Step 1 in part 1 is points for ultimate tensile strength. The sum of ultimate tensile strength of four materials is given by 850 plus 850 plus 1200 plus 950, which is equal to 3850, where 850 is ultimate tensile strength of low alloy steel, 850 is again ultimate tensile strength of plain carbon steel, then 1200 is ultimate tensile strength of stainless steel, and 950 is ultimate tensile strength of chromium steel. Therefore, for low alloy steel, the percent strength is given by 850 upon 3850, where 850 is again ultimate tensile strength of low alloy steel and 3850 is sum of ultimate tensile strength of four materials. Since weightage for strength given is 5, the points for low alloy steel are given by 0.22 into 5 is equal to 1.1. Let us consider this as equation A. Step 2 is points for hardenability index. The sum of hardenability index of four materials is given by 60 plus 80 plus 30 plus 100, which is equal to 270, where 60 is hardenability index of low alloy steel, 80 is hardenability index of plain carbon steel, 30 is hardenability index of stainless steel, and 100 is hardenability index of chromium steel. Therefore, for low alloy steel, the percent hardenability index is given by 60 upon 270, where 60 is hardenability index of low alloy steel and 270 is sum of hardenability index of four materials. Since weightage for hardenability is 3, the points for low alloy steel are given by 0.222 into 3, which is equal to 0.666. Let us consider this as equation B. Step 3 is points for cost. The points for cost are inversely proportional because a material with lower cost or points is a better material. The sum of cost factor is given by 1 upon 40 plus 1 upon 50 plus 1 upon 100 plus 1 upon 80, which is equal to 0.025 plus 0.02 plus 0.01 plus 0.0125. The addition of these four values is 0.0675. Therefore, for low alloy steel, the percent for cost factor is given by 0.0250 upon 0.0675, where 0.0250 is points for cost for low alloy steel and 0.0675 is sum of cost factor, which is equal to 0.37. Since weightage for cost factor is 2, the points for low alloy steel are given by 0.37 into 2, which is equal to 0.74. Let us consider this as equation C. Step 4 is total points. From equation A, B and C, the total points for low alloy steel are given by 1.1, 0.666, 0.74 is equal to 2.506. Part 2 is tabulation of weightage points. Similarly, total points for other materials are calculated and given in the following table. In this table, total points are calculated for low alloy steel, for plain carbon steel, for stainless steel, and for chromium steel. Part 3 is selection of material. The list of material according to descending order of points will be: first is chromium steel with 2.715 points. Second is plain carbon steel with 2.58 points. Third is low alloy steel with 2.506 points. And fourth one is stainless steel with 2.189 points. Therefore, for this particular application, chromium steel is selected as the best material of the component. By using the weighted point method, you can consider a material for any type of object. Thank you.